Okay guys, in today's video we are going to be proving that when you integrate cosec x with respect to x, you're going to get negative ln cosec x plus cot x plus c. So I'm sure you tried it by yourself based on the last video. You can actually check the playlist to see the last video, but just in case you've not done this before, we're going to break it down, break the steps down, and do it together. Alright, so let's go. Now you're given the integral of cosec x dx, and this is equivalent to the integral of 1 over the reciprocal of sine x dx. Okay, so the first assumption we need to make is let a be sine x, and as usual you're going to picture your imaginary right angle triangle. Okay, I'm going to picture an imaginary right angle triangle. So the right angle triangle that we're picturing is such that this angle here is x. So sine x is equal to a, or a over 1. This is opposite over hypotenuse, so opposite over hypotenuse. That means the adjacent side will be 1 minus the square root of 1 minus a squared. Okay, according to Pythagoras theorem. Okay, so now that we have made this assumption, let a be sine x, it has led us to using this particular imaginary right angle triangle, and we have gotten some identities that will help us in the future. So please, this is very important for this particular proof. Now you now want to change the variable of your integrand from x to a, so you do that by differentiating. So the a dx is equal to cos x. In other words, the a is equal to cos x dx. Now we'll make the x the subject of the formula. Making the x the subject of the formula gives me 1 over cos x dA. Is that okay? Now I'm going to make some substitutions into the original integral here. So this is the original integral. So the integral of 1 over sine x dx now becomes the integral of 1 over, in place of sine x I have a, and in place of dx I have 1 over cos x. What do you have? The a. Is that okay? So now that we've made this substitution, we need to find an expression for cos x. What is cos x? Of course, you got that right. Cos x is adjacent over hypotenuse. So cos x is equal to root 1 minus a squared over 1, which is actually root 1 minus a squared. So after making that substitution, you have the integral of 1 over sine x dx is equal to the integral of 1 over a, then 1 over the square root of 1 minus a square, that's for cos x, and dA. So you can see now that the integral is totally transformed in terms of a. Okay, so the integral, which is actually the integral of cosec x dx, is now integral of 1 over a, then dot 1 over the square root of 1 minus a square dA, which can still be 1 over a root 1 minus a squared dA. Okay, now how do we solve it from here? Still, we are going to make one more substitution, that let p be equal to the square root of 1 minus a squared. Okay, this is a very important substitution. So this integration is basically by substitution. Okay, everything surrounding the process of this integration is basically by substitution. So for p to be equal to 1 minus a squared, we're going to change the variables of our integration from a to p once again. Now p is equal to 1 minus a squared raised to the power of half, according to the law of indices. So the p dA is equal to, first of all, you bring down the 1 over 2, then you differentiate the bracket, giving you minus 2a. You rewrite the bracket, giving you 1 minus a squared, and you subtract 1 from the power of half minus 1. So we're going to have the p dA is equal to minus a into 1 minus a squared raised to the power of minus half. So this actually gives me minus a over the square root of 1 minus a squared. So I'm using the axiom that x raised to the power of minus half is actually 1 over square root of x. Okay, so it's still the same thing that you have here. So the a is equal to minus a over the square root of 1 minus a squared. So the implication is that the p is equal to minus a over the square root of 1 minus a squared. dA, in other words, dA is equal to the square root of 1 minus a squared over a. There's a minus sign here, dP. So you want to transform your integral. Remember, you want to transform your integral, which is in terms of a over here. You want to transform it from a variables to p variables. So let's do that together. So we have the integral of cosec x dx, which was formerly equal to the integral of 1 over a then root 1 minus a squared dA, is now going to be integral of 1 over a. Then we have let me just rewrite everything with 1 minus a squared. Then our dA is now going to be minus root 1 minus a squared over a dP. Okay, so you've made the substitution for dA to this particular one that you're seeing over here. So let's keep going in that vein. So our integral of cosec x dx now becomes, you can see now this cancels out this, right? And a times a is a squared, 1 times minus 1 is minus 1. So it reduces to the integral of minus 1 over a squared dP. Is that okay? So in other words, we have minus integral of 1 over a squared dP. So one other thing you want to remember is that you made p to be this 1 minus a squared. So if you square both sides, p squared becomes 1 minus a squared. So the implication is that a squared will be actually what? 1 minus p squared. So you can now substitute a squared into this place. So our integral of cosec squared x dx is now going to be minus integral of 1 over 1 minus p squared dP. Is that okay? So we're now going to use difference of two squares, 1 minus p, 1 plus p dP. So you're going to consider 1 minus p and 1 plus p, and you're going to split it into partial fractions. So this is a over 1 minus p plus b over 1 plus p, like this. So you're going to use cover up method. So a is going to be limiting value as p tends to what does p tends to? Just look for what you're going to put into this particular linear factor to make it 0, and it should be a 1. So in the original fraction over here, you're going to cover up 1 minus p squared, and you'll be left with 1 over 1 plus p. Sorry, you cover up 1 minus p, and you'll be left with 1 over 1 plus p. And when you apply the limit, you get 1 over 1 plus 1, which is 1 over 2. Then for your b, it's still the same thing. It will be limiting value as p tends to so you're going to ask yourself, what am I going to put into this linear factor to make it 0? Another way of doing it is 1 plus p equal to 0, then p is equal to 0 minus 1, p equal to minus 1. So this will be your minus 1. Then in the original fraction over here, you're going to write the original fraction and cover 1 plus p, so that you'll be left with only 1 over 1 minus p. Applying the limits, you get 1 minus 1, which is actually 1 over 2. So both a and b both a and b are 1/2. Okay, 1/2. So our 1/1 minus p, 1 plus p, is equivalent to half into 1 minus p plus half into 1 plus p, like this. So back to our integral. Our integral of sec, okay, not sec, sorry, our integral of cosec x dx is actually, remember, it was what did we have? We have minus into 1 over 1 minus p squared. Okay, minus 1 minus p squared dp, which we actually changed to 1 over 1 minus p 1 plus p dp, and which finally we now want to change to 1/2, then 1 minus p plus 1/2 1 plus p dp, like this. Is that okay? Then what we are going to do next is the integral of cosec x dx is equal to, so from this place factor out that 1/2, so it's going to be negative 1/2 integral of 1 over 1 minus p plus 1 over 1 plus p dp, like this. So when we distribute the integral, we'll have 1/2, open a big bracket, so you have integral of 1 over 1 minus p, right, dp, plus integral of 1 over 1 plus p dp, like this. So when you continue on like this, you're going to get minus 1/2. Then if you integrate this one, you're going to get what? Minus ln 1 minus p. If you don't understand how I got this, please try to watch my other video. You're going to see how I explained how to determine the integral of this kind of thing. I explained it very well, and if you apply the same rule to this one, you're going to get ln 1 plus p, like this. So plus constant of integration at the end of the day. Then what we're going to have is, I'm still going to reserve this minus sign here for some reason best known to the original persons who derived the formula. Rearranging what you have in the brackets, put the plus before the minus. You have ln 1 plus p minus ln 1 minus p, like this, plus c, then minus 1/2. Applying the law of logarithm, we have ln 1 plus p over 1 minus p plus c. So you have to recall that p itself is actually the square root of 1 minus a square, and from our reference right angle triangle, we had x, we had a, we had 1, and we had the square root of 1 minus a square. 1 minus a square is actually cos x, because x is adjacent to the hypotenuse. So cos x is square root of 1 minus a square, and this is equal to p this time around. So what you're going to do is the integral of cosec x dx, or this is cosec, is equal to minus 1/2. So anywhere you see p, just replace it with cos x. So you have 1 plus cos x over 1 minus cos x plus c. So if you apply this law of logarithm, you get a square root of this whole stuff, 1 plus cos x over 1 minus cos x plus c, like this. Then what do we do next? We have integral of cosec x dx is equal to minus ln, then I'm going to rationalize, right? the denominator of the sword. Rationalizing the denominator of the sword gives me this. You have 1 plus cos x multiplied by 1 plus cos x divided by 1 minus cos x multiplied by 1 plus cos x. So basically, when you rationalize, you're kind of like swapping the signs in the middle. So this is what you're going to have: minus ln square root of the numerator becomes 1 plus cos x all squared, and the denominator is kind of like difference of two squares, so 1 minus cos square x, then plus c. So if we distribute the square root symbol, integral of cosec x dx is going to be minus ln the square root of 1 plus cos x all squared divided by the square root of 1 minus cos square x. So plus constants. Now recall that sine square x plus cos square x is equal to 1. So anytime we see sine square x, we can call it 1 minus cos square x. Is that okay? So you're going to replace this guy over here with what? Sine square x, like this: negative ln square root of 1 plus cos x all squared, then all over the square root of sine square x plus c. So this is integral of cosec x dx. So this is negative ln. Now these two cancels out these roots. You have 1 plus cos x, and the same thing too cancels out the roots, so you just have sine x over here plus c. Now this is how this becomes. So you now have minus ln, you distribute like this, 1 over sine x. Okay, distribute the denominator term to all the terms in the numerator. That's what I mean. Then cos x over sine x plus c. So you have negative ln 1 over sine x is actually what? Good cosec x, and cos x over sine x is cot x plus c, and this is what we have as the integral of cos x dx. So proved.
Okay guys, let me explain one other thing just in addition to what we have seen here so far. You see this form of expressing our answer, this is just the informal way of writing it. The formal way of writing your answer to this particular integral is cosec x dx. The integral of cosec x dx should be minus ln absolute value of cos x plus cot x plus c, and the reason is like I explained in the last video. So you have to recall from these points that we had something like this before: ln square root of 1 plus cos x all squared
all over the square root of sine square x. So we had something like this from this particular step over here. Okay, so we just want to make some formal introductions so that you can understand why some things exist the way they are. Now remember, now when you take the square root of something, you have plus or minus but we are not going to use that approach for this line or this logarithmic function here, because we want to be careful the arguments that we feed to the logarithmic function. The best way to actually send the line function that notice is to actually house whatever the outcome of this ratio is. We can house it in an absolute value symbol, so that by the time we finish evaluating this, only the positive values or only the positive evaluations of the square root will actually exist in this case. So you now have minus line. Okay, we now use an absolute value symbol. So 1 plus cos x all squared, when you take the square root, it becomes 1 plus cos x, like this, and sine square x all squared gives you sine x. So we are not going to use the plus or minus, instead we are going to use the absolute values, okay, which in other words is actually the positive values. So evaluating it in this way, we are going to get integral of cos sec x dx is minus ln, okay, 1 over sine x plus cos x over sine x plus c, which gives me minus ln cosec x plus cot x plus c. Okay, so this is actually the more formal way of expressing the answer. So I hope you understood, and okay, that's it. This is going to do. So we've come to the end of the proof. I know I was rushing it, but I want to understand that maybe this is something that you've tried on your own several times and you've not been able to get it, but today you've gotten insight as to how to go about it. So I want you to take your time, if possible reduce the speed of the video so that you can follow me step by step if you truly want to understand everything that happened. I know it's a long proof, but don't be scared of the length. Just be all about understanding how and why I actually took all the steps I had to take during the course of the video. So I hope you really understood it. If perhaps there is something difficult or something that is not still clear, don't forget to leave me a question, leave comments, and if there are still some other proofs that you would want me to solve for you, leave it in the comment section and I'll be glad to attempt your question. So thank you for watching and stay tuned. Subscribe to my channel, like and share to your friends, share to lovers of mathematics, engineering mathematics, lovers of calculus, and let's build a community. Okay guys, see you later.